The formation of fossils. The remains of an animal or plant must find their way into water, sink to the bottom, and get quickly covered by sediment so that they don't decay or get scattered by scavengers. It is rare for a dead plant or a land dweller to land at the bottom of a lake or an ocean. This is why most fossils we have are of marine organisms. Once buried safely in the sediments, the hard parts of fossils are replaced by dissolved minerals. This creates a cast of a living creature. Then, the cast becomes compressed into rock by the sediments that pile on top. Fossils that lack hard parts are not easily fossilized. The first 80% of the history of life were all soft-bodied species. This is why we lack fossils of the earliest life on Earth. The fossil must then survive being obliterated by naturally occurring processes over a span of millions of years. Then, the fossil must be discovered. Given that all these conditions have to be in place for us to discover a fossil, we can see why the fossil record is incomplete. So far, we have only discovered about 250,000 fossil species. The total number of species that have ever lived on Earth is estimated to be between 17 million and 4 billion. Many missing links in the evolutionary history of organisms have been discovered and added on to our fossil record. These valuable fossils provide strong evidence for the evolution of living organisms, and without them our understanding of evolutionary history would not be as good. How exactly do we date fossils? We get the age of the fossil through radiometric dating of igneous rocks close to the fossil. We have been able to measure the actual ages of some rock through radioactivity since about 1945. How does radiometric dating work? Certain radioactive elements, called radioisotopes, are incorporated into the igneous rock when they crystallize out of molten rock from beneath the Earth's surface. These radioisotopes decay over a constant period of time. This period of time is called the half-life, and it is the amount of time it takes for half of the radioisotope to disappear. Chapter 2. Written in the rocks. Fossil evidence, I hope it doesn't stop. We're seeing evolution, it's all written in the rocks. Checking out the strata, it's the evolutionary clock. Older rocks at the bottom, younger rocks at the top. Complexity increases and it's written in the rocks. We came a long way from prokaryotes. See how life evolved, it's all written in the rocks.
In order to have a fossil record, fossils must first be formed. Ideally, the fossil record would have no missing layers, ensuring that a continuous record could be found. Typically, layers are lost due to erosion and other environmental factors that cannot be avoided. Missing layers can pose confusion when trying to identify the evolutionary changes a species went through. That being said, some organisms fossilize much better than others and therefore have a much better fossil record. Marine organisms, such as plankton, are the perfect subjects for fossilization because their bodies possess several hard parts which are easily fossilized. Plankton's fossil record is so complete that paleontologists can identify changes in the number of shell chambers over an 8 million year period. The figure shown graphs the number of chambers in the shells of plankton species over time. While the evolution waxes and wanes, we can clearly see an overall increase in the number of chambers. When evolving, species go back and forth, leading to an overall change when a trend line is placed onto a graph. The erratic nature of a fossil record is thought to be due to environmental and climate changes. Though evolution is seen in nearly all species, a species does not have to evolve. As a result, some species today are highly derived, while others still possess almost all ancestral traits. Through evolution, animals have gone from sea to land to air, and from land back to sea. These huge transitions are monumental in the history of evolution. However, a key part in understanding these changes is the transitional forms that act as intermediates between two very different organisms. Transitional species can now be identified by paleontologists even before they are found through the understanding of how transitional species work and what traits they should exhibit. Until about 390 million years ago, there were no land animals, only fish that lived in the sea. It was not until about 30 million years ago that the first tetrapod appeared in the form of an amphibian-like creature, quite different from the land-dwelling creatures we see today. Due to already existing fossil record, paleontologists knew what to look for in a transitional species. They knew the transitional form would be about 375 million years old and would live near fresh water. Armed with the information, paleontologists went into the field and discovered Tiktaalik, the transitional form between lobed-finned fish and early amphibians. These first land animals had flat heads, flat bodies, a distinct neck, and stubby fin-like limbs that could be used for pushing themselves up. Tiktaalik had two extremely important adaptations that prepared it for life on land. Sturdy ribs helped pump air into their lungs, and sturdier bones in their front fins created leg-like appendages. Though Tiktaalik wasn't ready for life on land, it paved the way for those that followed.
Ever since the 19th century, paleontologists saw the similarities between skeletons of birds and some dinosaurs and wondered whether or not they were somehow related to one another. The theropod dinosaurs lived around 200 million years ago and were fast, agile, bipedal carnivorous hunters. Paleontologists discovered modern bird fossils right next to 70-million-year-old rocks. Therefore, if evolution was true, you would be able to see transitional forms between the 200-million-year-old rocks and the 70-million-year-old rocks. And sure enough, their suspicions were correct. The missing link between reptiles and birds was actually known to Darwin, but he only saw it as an oddity. The whole scientific name is Archaeopteryx lithographica, and the specimen was found in a German limestone quarry in 1860. This special type of limestone was so fine-grained it created this almost perfect lithograph of the ancient species. Archaeopteryx became so famous because it was proof that a reptile could evolve to form wings and even the ability to glide or fly. But what really makes Archaeopteryx so important is that it looks very similar to older reptile fossils. The only bird-like features that Archaeopteryx possessed were large feathers and an opposable toe. These traits are very important because these skeletal forms tell us how reptiles were in fact the ancestors that brought about the evolution of birds. Probably the most remarkable of the fossils found was of a small theropod dinosaur which they named Sinornithosaurus meleni. The whole body of this small theropod dinosaur was completely covered in thin, long feathers, except its scaly chicken-like legs. There is one particular fossil that sheds light on how theropods didn't just look like birds, but they also had bird-like tendencies. The fossil is called Mei Long, which means soundly sleeping dragon in Chinese, and it is one of the small primitive bird-like organisms that lived over 135 to 110 million years ago. The behavior of roosting seems to have stemmed from that of primitive theropod birds, and therefore provides another piece of evidence that supports that theropod reptiles gave rise to modern birds. Is Archaeopteryx the modern bird's missing link? It seems very unlikely that paleontologists would stumble along the one and true common ancestor of all birds. Regardless, the fossils that Paul Sereno and others discovered clearly document the evolution of theropods to modern birds. We know theropods had feathers, but why were they desirable? Feathers didn't just have to be for flight in the beginning of development. They could have been for other things, like display, attraction, or even insulation. However, feathers didn't just pop out of nowhere. They evolved from the reptilian scales theropods already possessed. The evolution of modern birds from ancient theropod dinosaurs is a fact. The exact occurrences of certain evolutionary processes, however, is still unknown. Paleontologists have a very thorough fossil record of how land mammals evolved to form today's whales. Many fossils were found in the Middle East, and they help us understand the transition. We can even trace the steps of evolution. In Earth sediments around 60 million years old, we find plenty of fossil mammals, but no whale fossils. However, in Earth sediments around 30 million years old, we find fossil evidence of creatures that resemble whales that we see today. Therefore, we should expect to find transitional forms in sediments between 60 and 30 million years old. That is exactly what happened. fossils were found that spanned the gap. The transitional sequence from land mammal to whale starts with the fossil discovery of Indohyus. Indohyus is a relative to whales because it contained features such as whale-like ears, conical teeth, and it was also partly aquatic. We know Indohyus was aquatic because its bones are denser than terrestrial animals. Having denser bones would help Indohyus sink into the water instead of float and bob about at the surface like terrestrial animals. The true ancestor of modern whales is the 52-million-year-old wolf-sized fossil called Pachycetus that was discovered in the Kuldan Formation of Pakistan. Pachycetus didn't look anything like modern whales do today, but it is Pachycetus's close relatives that are the ones who gave rise to modern whales due to dramatic adaptive radiation. Around 50 million years ago, there lived an animal with an elongated skull and reduced limbs. This remarkable creature was accurately named Ambulocetus, which literally means walking whale. Rhodocetus is the next transitional form in the evolution of whales. Rhodocetus was more adapted to the water due to the fact that its nostrils were located further back rather than on the tip of its face. Since this is the first transitional form to show the migration of the nostrils, it is very important because this was a serious adaptation towards life in the water. The evolution of whales took place within 10 million years, which is a remarkably fast transition in terms of geologic time. The time it took hominids to diverge from our common ancestor with chimps took not much longer than 10 million years. However, hominid transition didn't involve such dramatic changes of limbs and body design. Since it took millions of years for fish to invade land, why would they all of a sudden want to descend back into the water? Large marine carnivorous Mosasaurus, Ichthyosaurus, and Plesiosaurus all of a sudden went extinct and allowed the small aquatic animals to invade the water.
You don't need to believe it cause it's true. Yes, it's evolution. Fossils are the proof. So are living animals. We evolved too. I highly recommend it that you read this book.
The fossil record teaches us 3 things. First, the record, laid out in the rocks, provides proof of evolutionary theory. This is because we can see things like the gradual change within lineages, the splitting of lineages into new species, and finally, the existence of transitional forms between 2 very different types of organisms. This evidence is unwavering proof that evolution happened. Secondly, we find transitional forms precisely in the strata that they should be located. Examples include the earliest birds appear after dinosaurs but before modern birds. Another example is that ancestral whales span the gap between land mammal ancestors and fully aquatic mammals. If evolution weren't true, you would see transitional fossils in strata that wouldn't make sense. Finally, the fossil record teaches us that evolutionary change always involves remodeling the old into the new. Evolutionary biologists would ask, why start from the ground up when you already have a solid foundation to start from? Natural selection acts only on remodeling existing features that the organism already possesses and fashions them into new ones. The only thing natural selection cannot do is produce new traits out of thin air. Therefore, Darwinism predicts that new species will be modified versions of older species, and the fossil record provides evidence for that.
Now you understand the topic. Evolution is just logic. I'm kinda serious, it's written in lineages. The dates of fossils, they fit, you gotta know it's legit.